So, hello everyone. This is the third question of today's LeetCode contest, and it's very interesting. We'll see the solution. And before jumping to the solution, please, if you're new to the channel, please hit the subscribe button because we are coming up with very awesome content where I made each problem solution very easy for you and intuitive. And we'll see what wrong mistakes you can do when you're approaching a problem. And let's try to solve this question and get started. Right. So, and also we have hit the 250 subscribers milestone. And thanks you for all guys. And then yeah, we'll go ahead with more such milestones. So the question says count Bowl Subarrays. Okay. You're given an integer array nums with distinct elements. Okay. Distinct is a very important keyword. Very, very important. Mark in mind. I will tell you that later how it matters. Whenever these kind of things in bold happens, right? You have to think about something like that as well. Subarray nums is called a bowl. The subarray is at least length 3. Okay. Cool. The minimum of its two ends is strictly greater than the maximum of all elements is in between. Hmm. Okay. What it says is that when you pick two elements, let's say L and R, you pick a subarray, you pick all the elements in the middle should be smaller, and these elements strictly, obviously, it will be strictly only because the elements are not same itself. So yeah, strictly small. Means these elements are smaller and these elements are together. And the minimum of both of them should be larger than all the elements. So basically, minimum of ARR, whatever nums, right? I think it's nums. Yeah, it's written already. Minimum of nums of LR, it's greater than all the middle elements. And I have to return the number of bowl subarrays in nums. So obvious question comes to your mind. Okay, the first solution that comes to your mind, yes, that's obvious. I won't want to tell it, but yeah, O of n square, right? Generating all subarrays, checking the condition, and we won't spend much time there because that's not useful, right? Let's try to jump off to the main part and how you think about that and how I thought about in the contest and try to solve this within the contest itself. Okay, so let's try to understand. See, actually, explain me one thing. If let's say our number is 5, 6, 7, 3, 9, 1. Okay, so when you either the first thing comes to your mind, okay, let's traverse and do something. We what we want that the top two elements, right, in that subarray should be the starting and ending. I hope this you get it, right? Starting and ending. That means the second largest element you can think of something like that should be larger than that. Should come to your mind. Second larger element is a main intuition here. Second larger element. So what we will do, we'll see later. But yeah, this is the one thing you should keep in mind. Okay, okay. So first thing was into my mind during the contest, which was wrong eventually. I thought top two elements I got it. That okay, the last top two elements will be there. But I thought of using a heap, maintaining top two elements of the continuous traversal and then check. But you cannot able to calculate all the subarrays efficiently. It turns out I dropped my idea and I moved to the different thing. See, let's try to draw what will happen. What are the possible situation? Let's say I'm drawing L and R, something like that. This is a possible situation. One possible situation, one possible subarray. What else subarray it could have? This is also possible. Right, more subarrays could be there, but these are the possible. Why these is possible? Because all elements are smaller than this and these are too larger. These are too larger. Any of them could be larger, there is no problem there. Okay. So what do you think, let's consider each element as a left thing and each element as a right thing, and then try to calculate the subarray. And obviously you are able to understand, right? That's we have to do this efficiently. That's all the crux is. Because in middle we won't get subarrays. Don't think about two pointers here. Because why? It's not like that if this is the solution, then in the middle also you'll get a solution. You won't get a solution, right? Only a perfect solution you will get. Okay. Now let's try to think. So what my intuition that comes to my mind is, consider each element of nums as first the left side and second right. Okay, we'll see how we can help this. Cool. And tell me one thing, that obviously if it is a left side, that means what? The left side, all the elements on the leftmost sides are smaller than that, right? All the elements on the left side are smaller than that. So if I consider this a subarray, like whatever I'm subarray I'm considering, okay. So if I consider, let's say left is there, right? What I will do, I will jump off and find another point, and I will explain you what, until I found a next greater element than this. Okay. So what I'm doing, that is actually a monotonic stack problem. That's another intuition. If you, I give you a hint, it's a monotonic stack problem. Try to think what how we can do that. See, we are at L. Okay. We are doing this, we are doing this, we are doing this. Will we do, will do until then we found another element which is greater than this, which is greater than this. Okay. Which is greater than this. Until then, we will keep doing that. Okay. And we will consider this as one end and this is one end. Okay. This is one end and this is one end. Obviously, you got it right. This will be the second largest element according to this, because these elements are smaller. This element is larger. This is second largest. Right. Right. Now, what is the condition that this will form a valid subarray? That this element, and at least one element should be in between. That means the next greater element index, greater element index minus current I should be greater than equals to 2, right? Should be greater than equals to 2, right? Yeah, that makes sense. That makes sense. Then only it will form a valid subarray, right? Same thing, same concept we will apply. We'll go to the left side as well. We will consider this as the rightmost thing. And then what we'll do, we'll find another next greater element on the left side. Interesting. Interesting. This is quite cool. And same thing will apply. The next greater right element and the next greater. And now this time it will be reverse. I minus next greater left element. I'm storing the indexes, not the values in the next greater. Okay. That's why I'm doing the difference. Should be greater than equal to. Same logic. That should be at least size of 3. So it should be like that. So do you get a quite intuition? Okay, what I did, I fixed one element and I treat it as okay, this would be the left mine. Then I will find the right of it. Same thing. What I'm doing is I'm fixing the right and like this is again the nums of I only. I'm considering the nums of I as the two things. These are independent. These are separate things. There won't be any overlap in between. I hope you're getting it right, because this is time. This is second largest element again. So the idea is to treat every element as the second largest element, and you should know something about monotonic step. So I hope you, if you don't know about it, do let me in the comments that you don't know about monotonic stack. This is a standard thing everybody knows. That what it does is, given a number, you can find the next greater element. Next greater element. If you don't know about it, do let me know in comments. I will make a video out of it that as well. But yeah, I think you must have known this as well. Similarly, on right side, I will calculate an array on the left side. Previous greater element, previous next greater element. Means you can say that left greater element. The previous you can say actually greater element. Okay. Since all elements are unique, that means there is no problem of the duplicacy, right? Everything it will be greater only, or it will be lesser only, right? Cool. And then what we will do? We'll just maintain this, and for every element, we'll check one time for this, one time for this, and we'll, if this possible, answer plus one. If this possible, answer plus one, and boom, our job is done. And finally, we will get an answer, right? So the solution is very simple. Just try to get the intuition. The second largest thing, draw this diagram. These diagram are the crux. Yeah, can you consider these cases? Okay. Now let's try to see with an help of an example as well that how can we do that. So let's say 5, 6, 7, 9 only I did that. 5, 6, 7, 9, 1. Okay. So what is the largest element? There's nothing is there. Okay, what is the largest element here? Next, this is 6. But are they, is there any element in between? No. So I cannot consider 5 in my left. Can I consider it to be this though? I cannot consider because nothing is there. So then also though 5 ignored. Let's consider 6. What is the next larger? Because nothing is there. So on the left side there is no answer. Is there an answer on the right side? Oh, the answer is again there is no answer on the right side as well. Why? Because the next larger is this only, and this difference is 1. It's not 2. So skipped again. 7 also. Let's see. The next larger, nothing is there. So let me just consider another example. I think this is I made a continuous, so it won't make any sense. So let us consider the example 2, 5, 3, 1. Okay. Let's try to and let's say 8. Let's try to think like this. This is, let's say, 6. We'll try to see. Okay. So let's try to see if there is any next larger. There is no next larger for this. For previous, no, won't we get it? For this, try to understand. Now try to understand. Next larger is, previous larger is this. Next larger is this. Right? So you will get but. Try to understand. Try to understand. We're not doing like that. We're not doing like that. People can get confused like this. We are not doing like. Firstly, we'll consider only the left part, but it's less than 2. It won't get an answer. Again, the right part, only 2 elements. We won't get an answer. We want the difference should be greater than 2, right? That means the difference should be greater than equals to 2. The total n should be 3, right? But the array is 2 only here, right? The difference is only 1. But now consider this. Consider this. Now this is important. If you go here, did you see something? You find a element 8, 2, 5. This is, and your answer, yes, it is. Why? Because this is smaller. Minimum of that. Same thing. Go for right side as well. You will get an answer because one element in between. You will get two answer from here. Okay, same thing. Let's try to go further. Will 3 we get an answer? No, because again 2 here, 2 here. There is only difference of 1. We won't get an answer. Here will we get an answer? Yes, we will get an answer. 8, 2, 5, 3, 6. On the left side, we'll get an answer. The only one answer we will get here. Two answer we will get here. Answer is 3. So this is the whole intuition that what we get, right? We firstly consider on the left side, then we consider on the right side, and then we can independently sum them up. Let's try to move to the code to understand you better. Okay, so this is a standard code that what we n size I've taken, and then I've calculated the leftmost greater element, next greater left element, and next greater right element in L and R. I maintain a stack. Okay, then this is a standard code of a monotonic stack. How, what do you do that? So firstly, you for leftmost greater element you fill with -1 and you traverse like this, right? So and then for the rightmost greater element you traverse like this. Let's say you get and you keep popping out until for, let's say, firstly let's calculate the leftmost greater element until your nums of I is greater than your the previous elements in the st dot top. You just keep popping out the elements, and once you get an element which is larger than your current element, you just keep that safe, and then you just put, if it is not empty, means obviously if there is some element, that means that index is the next greater element for this particular index, right? If you don't understand this, do let me know. I will make a entire video on, because this focus was not monotonic state. The main focus was the intuition about the next second largest element. Same thing, what we do on the right side, what we'll do, keep popping out until our nums of I is greater than the rightmost element, right? In the our stack. We keep popping out because this is smaller, right? All elements in the stack, whatever we keep are smaller. We keep popping out until then one element turns out to be larger. And that element is the next element, next greater element. Okay. We maintain these arrays. Okay. Next. So basically these are the indexes array we will get. Now what we do, it's very simple, right? Firstly, we'll check there any next left greater element. Yes, it is. If it is there, means L is not equals to -1, and the difference current element Li is greater than equals to. See, this is 0. If it is 1, the difference is only 1. There should be at least difference of 2. That means the 3 element, because the subarray length is Li minus I plus 1. Right? That's why it's say you can do that as well, or you can do 2 as well. Same thing, we go on right side. Is there any greater element, next greater element? Yes, if it is there, means it's not equals to n. And if the difference is greater than 2, we'll do answer. They are both independent operation, and finally we return. It's a very beautiful question of the monotonic stack. You will get the idea once this solution is uploaded. But yeah, that's a beautiful problem. I liked it. And if you have any doubts, do let me know in the comments. I will happy to answer that. And if you haven't subscribed to the channel, if you like the content, make sure to hit to the like button. It will motivate me to make such more awesome content. Cool. See you then in the next videos. Bye bye.